You know, in software design, getting different objects to work together in perfect harmony can be a real headache. But what happens when you need to create entire families of related objects without painting your system into a corner with hard-coded classes? Well, today, we're diving deep into the abstract factory pattern, which is an absolutely brilliant solution to this exact problem. So let's imagine you're building a furniture shop simulator, and you've got these distinct styles, right? Modern, Victorian, Art Deco. The absolute last thing you want is for your code to accidentally pair a sleek, minimalist modern sofa with an over-the-top ornate Victorian chair. I mean, that's not just a style clash, it's a fundamental problem in your code that shatters the user's experience. What we're aiming for is harmony, where every single piece created for a set is guaranteed to belong to that set. And this right here, this is precisely the problem the abstract factory pattern was born to solve. The core idea, its whole purpose, is to let you produce families of related objects, like that complete, harmonious, modern furniture set, without ever forcing your main application code to know about the nitty-gritty details of specific classes, like modern sofa or Victorian chair. So, how do we achieve this beautiful consistency? The solution is really elegant. It's what we call a factory of factories. Think about it not as a single factory that builds the furniture itself, but as a master factory whose only job is to produce other highly specialized factories. Each of these subfactories is an expert in producing one and only one consistent style. Okay, the first crucial step to making this work is abstraction. We have to stop thinking about a specific modern chair and start thinking about the general concept, the interface of a chair. The pattern requires us to define these abstract blueprints for each product type, and then we define an abstract factory interface, basically a contract that promises to provide methods for creating each of these abstract types, like create chair and create sofa. All right, let's get into the weeds and break down the architecture. To really get the abstract factory pattern, you need to understand its four essential components. These parts all work together to give us that powerful flexibility and, most importantly, to guarantee that our products are always compatible. This matrix you're looking at illustrates the core concept perfectly. See how the rows list our abstract product types? We've got chair, sofa, and coffee table. The columns, on the other hand, represent the different style families, or variants: modern, Victorian, Art Deco. The entire goal of an abstract factory is to let us create a full column of products, a complete family, while making it impossible to accidentally mix in items from any of the other columns. So how do these four components actually work together? Well, we start with our abstract products. These are the blueprints, the interfaces, like chair. Then we have concrete products, which are the real objects built from those blueprints, like a modern chair. Now, to manage all this creation, we defined an abstract factory interface, which is our contract for making these products. And finally, we implement concrete factories, like a modern furniture factory. This factory's sole responsibility is creating an entire family of only modern products, ensuring perfect, foolproof compatibility. Theory is one thing, but let's see this pattern in action where it really shines. A perfect real-world scenario is building a cross-platform application. You want your app to look and feel native on every operating system, right? That means it needs Windows-style buttons on Windows and Mac OS-style buttons on a Mac. This is a classic textbook abstract factory problem. So we start by defining our abstract factory interface, which we'll just call GUI factory. This is our contract. It declares methods for creating every single UI element our app might need, like create button and create checkbox. And pay close attention to the return types here. They're also abstract interfaces like button and checkbox. They are not specific implementations like win button. That part is key. Next up, we implement our concrete factories. We'll have a win factory that fulfills the GUI factory contract by creating actual win button and win checkbox objects. And, of course, we'll have a Mac factory that does the exact same thing, but for the Mac OS style controls. Each factory is a specialist, an expert in producing a consistent family of UI elements for its specific operating system. And now, this is where the magic happens. Look at the client code, our application class. It has zero idea if it's working with a Win factory or a Mac factory. It only knows about the abstract GUI factory interface. This is the heart of decoupling. The application can just ask for a new button, and it gets a compatible one without ever needing to know the messy details of the underlying operating system. So you're probably wondering, where does the decision get made? It happens right at the very beginning. When the application boots up, a tiny piece of initialization logic checks the environment, sees, hey, I'm running on Windows, and creates a new WinFactory. That single decision, made only once at the start, dictates the entire look and feel of the UI for the app's whole runtime.
Okay, we've seen the problem, we've seen the structure, and we've walked through a practical example. So let's get to the verdict and see how this all balances out. What are the pros, the cons, and when should you actually reach for this pattern in your own projects?
The benefits here are pretty significant. First, you get an ironclad guarantee of product compatibility. You also achieve loose coupling, separating your client code from the concrete implementations. And as a bonus, you're following key solid principles like single responsibility and open/closed. But there is a trade-off: complexity. This pattern introduces a lot of new interfaces and classes, which can definitely feel like overkill for simpler projects. So when should you pull it out of the toolbox? You should use the abstract factory pattern when your system needs to be configured with one of several different families of products. Use it when you want to provide a library of products without revealing their specific implementations. And here's a little pro tip. If you ever find a class that's just full of a bunch of factory methods, that's often a huge signal that it's time to extract all that creation logic into a proper abstract factory. So there you have it. The abstract factory pattern is an incredibly powerful tool for enforcing consistency and enabling real flexibility in your system's architecture. The question I want to leave you with is this: where in your own codebase are you maybe creating objects that could lead to chaos? And could this pattern be the key to bringing them all back into perfect harmony?